Have you ever gazed into the night sky and wondered, are we alone in the universe? You're not the only one. This question has driven humanity for centuries, leading us to the edge of our understanding and beyond. Our curiosity has taken us to the moon, sent rovers to Mars, and now it's leading us to distant worlds known as exoplanets. You see, these celestial bodies could hold the answers to our profound questions about the existence of life beyond Earth. Exoplanets, worlds orbiting stars other than our sun, represent a new frontier in our cosmic journey. They offer tantalizing prospects in the search for habitable worlds and potential extraterrestrial life. As we peel back the layers of the universe's mysteries, we're discovering that these distant planets may be more common and more diverse than we ever imagined. The answers to these questions could lie billions of miles away, on planets circling stars beyond our solar system. So what exactly is an exoplanet, you might ask? An exoplanet, short for extrasolar planet, is a planet that orbits a star outside of our solar system. Unlike the familiar planets we grew up learning about, exoplanets are not bound by the gravitational pull of our sun. Instead, they dance around distant stars, each carrying out its own cosmic ballet. Now, you might be envisioning exoplanets as just larger or smaller versions of what we have in our solar system. But exoplanets are as diverse as the stars they orbit. From gas giants larger than Jupiter to rocky worlds no bigger than our Earth, the variety is truly staggering. Some are scorching hot, others freezing cold. Some exoplanets even orbit within the habitable zones of their stars, where conditions might just be right for life as we know it. In the vastness of the cosmos, these celestial wanderers silently orbit their parent stars, waiting for us to uncover their secrets. How do scientists even find these distant worlds? Well, it's a cosmic game of hide and seek. And we've got some pretty clever ways of spotting these elusive exoplanets, even though they are light years away. There are three main methods we use: the transit method, the radial velocity method, and direct imaging. Let's start with the transit method. Imagine you're sitting in a park, watching a street lamp as the sun sets. Suddenly, a bird flies across, momentarily blocking the light. That's essentially what the transit method is. Astronomers monitor the brightness of distant stars, and if there's a dip in the light, it could mean an exoplanet is passing in front of the star, or transiting. The size of the dip can even tell us about the size of the exoplanet. Then we have the radial velocity method. Picture a tug-of-war game. Even though one side might be stronger, there's always a bit of movement from both sides. Similarly, as a planet orbits a star, it doesn't just go around in a perfect circle. It tugs the star a little, causing it to wobble. This wobble creates changes in the star's light that we can detect here on Earth, allowing us to infer the presence of a planet. Finally, there's direct imaging. This is like trying to spot a firefly next to a lighthouse from miles away, except the firefly is the exoplanet and the lighthouse is the host star. This method is challenging due to the overwhelming brightness of the star compared to the planet, but with the help of advanced technology, we're making progress. All these methods might seem like looking for a needle in a cosmic haystack, but they've proven incredibly effective in the search for exoplanets. They allow us to peek into distant corners of our galaxy, uncovering worlds we could only dream of. These methods, like cosmic detectives, help us unveil the mysteries of the universe, one exoplanet at a time. What have we learned from our cosmic explorations? Well, the world of exoplanetary research is riddled with fascinating discoveries that continue to reshape our understanding of the universe. Let's delve into some of the most notable ones, shall we? Take Kepler 22b, for instance. Discovered by the Kepler Space Telescope, this exoplanet is one of the most promising candidates in our search for Earth-like planets. It orbits within its star's habitable zone, the region where temperatures might just be right for liquid water to exist. Imagine that water, a basic requirement for life as we know it, potentially existing on a world beyond our solar system. Then there's HD 209458b, also known as Osiris, the first exoplanet confirmed to have an atmosphere. This gas giant, similar in size to Jupiter, surprised us by having an atmosphere rich in carbon and oxygen. It's a harsh and inhospitable world, but its discovery marked a significant milestone in our journey to understand the nature of distant planets. Let's not forget Proxima Centauri b, the closest known exoplanet to us, orbiting the nearest star to our Sun. This rocky world, potentially habitable, is a tantalizing target for future space missions. Imagine the wealth of data we could gather if we could reach this celestial neighbor. And then there's K218b, the first exoplanet discovered to have both water in its atmosphere and temperatures in the habitable zone. It's not exactly Earth's twin, but it's a prime example of the diversity of exoplanets out there. Each of these discoveries has its unique characteristics, giving us insights into the vast array of worlds that exist beyond our solar system. They also highlight the potential implications for astrobiology, the study of life's origin, evolution, and distribution in the universe. The existence of these diverse exoplanets, some potentially habitable, fuels our curiosity and strengthens our resolve to keep exploring. Each discovery brings us one step closer to answering the age-old question, are we alone in the universe? Only time and continued exploration will tell, but one thing is certain, the universe is full of surprises, and we've barely scratched the surface. What does the future hold for our exploration of these distant worlds? As we delve deeper into the unknown, the field of exoplanet research is poised for a revolution. The journey thus far has been remarkable, but brace yourselves because we're just getting started. In the coming years, we will witness the launch of numerous new missions and the development of cutting-edge technologies that will significantly enhance our ability to study these far-off worlds. The James Webb Space Telescope, for instance, set to launch in the near future, will carry instruments capable of detecting the chemical fingerprints of water, methane, oxygen, ozone, and other components in the atmosphere of an exoplanet. These are known as biosignatures, the possible indicators of life. Another exciting prospect is the Plato mission by the European Space Agency, aiming to discover and study a large number of Earth-like planets orbiting Sun-like stars. Plato's high-precision cameras will enable us to detect and analyze the rocky planets in the habitable zone where liquid water could exist. The future also holds the promise of advancements in direct imaging techniques. Imagine being able to capture an actual image of an exoplanet, seeing its colors, weather patterns, and perhaps even its surface features. This could become a reality sooner than you might think. However, the path to these advancements is not without its challenges. The search for smaller Earth-sized exoplanets, for instance, is a complex task. These planets are faint and easily lost in the glare of their host stars, making their detection a feat of astronomical proportions. Likewise, the search for biosignatures is fraught with difficulties. Interpreting these signatures requires us to understand the planet's atmosphere, its host star, and even the planet's geological activity. Despite these challenges, the future of exoplanet research is undeniably bright. As we continue to push the boundaries of our knowledge and technology, we inch closer to answering one of humanity's oldest questions. Are we alone in the universe? As we stand on the brink of new discoveries, the universe awaits, full of mysteries yet to be unraveled. Our journey into the cosmos is far from over, and the best is yet to come. Stay tuned, because the next chapter in this grand cosmic tale promises to be an exhilarating ride. Why should we care about these distant worlds, you might ask? Well, let me tell you. Exoplanets are like frontier outposts, pushing the boundaries of our understanding of the universe. They are cosmic laboratories, each one unique, each one teaching us something new about the grand tapestry of existence. The significance of exoplanets is not limited to the scientific realm alone. They raise profound philosophical questions, reshaping our understanding of our place in the cosmos. Are we alone? Is Earth unique, or just one of many life-bearing worlds scattered across the universe? The discovery of life beyond Earth, even in its simplest microbial form, would be a watershed moment in human history. It would redefine our perception of life's rarity and resilience. Scientifically, the study of exoplanets opens up new avenues in various fields, from astrophysics to chemistry, from climate science to biology. Understanding the atmospheres of exoplanets, for instance, can provide insights into their climate and potential habitability. It helps us understand how life might survive under different conditions, broadening our definition of what constitutes a habitable world. But it's not just about science and philosophy. Exoplanets also have practical implications. The technologies developed to study these distant worlds have applications here on Earth. The algorithms used to analyze exoplanet data, for example, are now being used in medical imaging. And let's not forget the potential for exploration. As our technology advances, exoplanets could become targets for future robotic or even manned missions. Who knows? Perhaps one day some of us or our descendants might call an exoplanet home. In the grand scheme of things, studying exoplanets is about more than just satisfying our curiosity. It's about understanding our place in the universe, expanding our horizons, and preparing for a future where humanity might not be confined to just one planet. As we continue our cosmic journey, remember, each star in the night sky could be a sun to another world, a world that might not be so different from our own.